This video is about proving statements about angles and segments, and we're going to introduce the congruent supplements theorem, which says if two angles are supplementary to the same or congruent angles, then they are congruent. So let's take a look at maybe an illustration of this. These are not, I'm going to draw some angles. They are not drawn to scale. And we remember that supplementary angles have to add up to 180 degrees. And let's say this is angle 1 and angle 2. And let's say that we know that the measure of angle 1 plus the measure of angle 2 is 180 degrees. All right. Now let's say that we also have another angle, like so, which we'll call angle 3. And let's say that we also know that the measure of angle 3 plus the measure of angle 2 is 180 degrees. Well, angle 2 is supplementary to angle 1. Angle 2 is also supplementary to angle 3. So therefore, the measure of angle 1 is going to have to be equal to the measure of angle 3. So angle 1 is going to have to be congruent to angle 3 according to the congruent supplements theorem. Now next we have the congruent complements theorem, which says if two angles are complementary to the same or congruent angles, then they are congruent. Again, this is not drawn to scale. This is just a sketch. Let's say we have two angles here. And they are angle 4 and angle 5. And let's say we have another angle over here, angle 6. So let's say that we know, now remember, angles that are complementary add up to 90 degrees. So if we know that the measure of angle 4 plus the measure of angle 5 is 90 degrees, and let's say that we also know that the measure of angle 4 plus the measure of angle 6 is 90 degrees. So angle 4 and angle 5 are complementary, and angle 4 and angle 6 are complementary. So we'll have to conclude that the measure of angle 5 is going to have to be equal to the measure of angle 6. Or, according to the congruent complements theorem, angle 5 must be congruent to angle 6. So let's move on. Next, we're given the linear pair postulate, which basically says if two angles form a linear pair, then they are supplementary. So let's just refresh our minds on what a linear pair looks like. These are basically a linear pair are two angles that share a common side, and they create a straight line together. So here's angle 1 and angle 2. Well, if they create a straight line together, remember a straight line measures 180 degrees, so it makes sense that a linear pair, the measures of their angles together would add up to 180, which does make them supplementary. So we'll say angle 1 and angle 2 are supplementary. Now next is a concept that we have talked about before. This is the vertical angles theorem, which just basically says vertical angles are congruent. So let's say we have these angles, 1, 3, 2, and 4. Angle 1 and angle 3 are vertical angles, so angle 1 must be congruent to angle 3. Angle 2 and 4 are vertical angles, so angle 4 must be congruent to angle 2. Moving on. It says that angle 2 and 3 are a linear pair. Angle 2 and angle 4 are a linear pair. And angle 2 and angle 1 are vertical angles. And we'd like to say whether or not the following statements are true or false. Okay, so this is what I want you to do with that information. Now let's see if we can draw a picture of this. Okay, so angle 2 and angle 3 are a linear pair, so we know that they are right across from each other. We also, not across from each other, I'm sorry, we know that they make a straight line. Angle 2 and angle 4 are a linear pair, so they make a straight line. And angle 2 and angle 1 are vertical angles, so they are the ones that are right across from each other. So let's see if we can just draw a picture of this and label it accordingly. So here is, let's say angle 2 and 3 make a straight line. They're a linear pair. Angle 2 and 4 make a straight line. They're a linear pair. And 1 and 2 are vertical angles. They're across from each other. So let's take a look at this. Is angle 1 congruent to angle 2? Yes. Why? Because we know that vertical angles are congruent. Angle 2 and angle 3, we want to know, do they add up to 180 degrees? Yes, because a linear pair is supplementary. So that's true. We want to know, is angle 3 congruent to angle 4? Yes, they're vertical angles. So that's also true. Now, what about angle 2? Would angle 2 be congruent to angle 3? Well, we don't know that. In fact, looking at our picture, the only thing we really know is that angle 2 and angle 3 are a linear pair. So, if they're a linear pair, that does not prove that they're congruent. It could be if they were both 90 degrees, but we don't know that information. So, we are going to have to say that that is false. So let's move on to our next page. And we're given this picture. It is not drawn to scale, but we're given some information. We're told the measure of angle CHE. So CHE is 90 degrees. So this part right here is 90. We are told that DHF, so DHF is also 90 degrees. And we are told that the measure of angle AHF is also 90 degrees. Well, you can see right off, this is definitely not drawn to scale. But we are given some information down below. We are asked if the measure of angle 2 is 32 degrees, then what would be the measure of angle 6? Well, if you look at these two angles, they are vertical angles. So vertical angles are congruent, so the measure of angle 6 would have to be 32 degrees. Next, you're asked if the measure of angle 6 is 36 degrees, what would have to be the measure of angle 4? Well, let's think about it. Angle 6 and angle 5 are complementary. Angle 4 and angle 5 are complementary. So by the congruent complements theorem, we know that angle 4 and angle 6 must be congruent. So angle 4 would have to have the same measure as angle 6, which is 36 degrees. Next, they're asked if the measure of angle 2 is 34 degrees, what would the measure of angle 3 have to be? Let's think about it. Angle 4 and angle 5 add up to 90. And angles 2, 3, 4, and 5, it seems, all form the straight line together. So angle 2 and 3 would also have to add up to 90 degrees to get a straight line equal to 180 degrees. So if angle 2 is 34 degrees, we would have to take 90 degrees minus 34, which would give us 56 degrees. Lastly, we're given that the measure of angle CHF is 118 degrees. We would like to know what the measure of angle 2 is. Well, let's think about it. Angle 2 and angle 6 are vertical angles, and so they would be congruent. So if we could find the measure of angle 6, we would know the measure of angle 2. Well, if we think about it, CHF is 118 degrees. Angles 4, 5, and 6 make up angle CHF. Angles 4 and 5 equal 90 degrees. So if I took 118 degrees minus 90, I would end up with 28 degrees for the measure of angle 6. So the angle 6 and angle 2 are vertical angles, so angle 2 would also have the same measure, since it would be congruent to angle 6, and angle 2 would equal 28 degrees. So you can see we're using our theorems to actually use some reasoning to actually find out the angles, the measure of angles in these diagrams. We'll be continuing to do this in class. Thank you for joining me.